For centuries, economics has had, well, a pretty serious case of physics envy. It's been on this long, long quest for scientific certainty in a world that's driven by messy, unpredictable human behavior. And this whole struggle, this entire identity crisis, it really boils down to one simple but, let's be honest, super provocative question.
Yeah, that's the one. Is economics actually a science?
I mean, people get really, really passionate about this. You just have to hop on a forum like Reddit, and you see stuff like this. Economics is just capitalist voodoo with some math and psychology thrown in to make it seem legit. Wow, strong words, right? But honestly, that quote just hits the nail on the head. It perfectly captures the heart of the debate we're going to dive into.
So let's start there. Let's really dig into this idea, this physics envy.
You see, at its heart, this whole envy thing is really about a deep-seated desire for academic respect. Economics wants to be seen as a hard science, like physics or chemistry. And to do that, it's tried to copy them. It's adopted their language, their rigor, and boy, has it adopted their math. And this is where you can really see the problem. In physics, you've got these universal constants, things that are always true. You can set up an experiment in a lab, control all the variables, and get the same result every single time. But economics? Its biggest variable is, well, it's us. It's unpredictable human beings. There are no universal constants to be found, and you can't exactly stick the entire global economy in a test tube and run a controlled experiment.
So you might be asking, how in the world do economists even try to deal with this mess? Well, they have a tool, a kind of intellectual cheat code. It's a Latin phrase, ceteris paribus. It literally means all other things being equal. It's an assumption they use, where they just pretend that every other variable is held perfectly still so they can look at the impact of just one thing. But, and this is a huge but, as our friend on Reddit pointed out, this means their models are built on, well, imaginary systems. They're not describing the real world in all its chaotic glory.
Okay, so what if the answer wasn't to create more and more complicated math based on imaginary worlds? What if the answer was to use a real, concrete law of physics? Well, that brings us to our next big idea, the law of entropy.
So, yeah, instead of just trying to make economics look the part, dressing it up in fancy equations, this one economist, Nicholas Georgescu-Roegen, he had a much more radical idea. He wanted to rebuild the entire field on a fundamental law of physics itself. And that law was entropy.
And you have to understand, this guy was not your typical stuffy academic sitting in an ivory tower. I mean, what a life. He was born in Romania, got his PhD in Paris, then went to Harvard and was mentored by the absolute legend Joseph Schumpeter. And then, get this, he had to flee communist Romania as a political refugee, literally hiding away on a freighter ship. I mean, you can imagine how a life that dramatic would shape your thinking, right? It all led to his masterpiece in 1971, The Entropy Law and the Economic Process.
So what was this huge radical idea? Well, the entropy law in economics is pretty simple on the surface, but its implications are massive. It basically says that every time we use a natural resource, any resource, it gets irreversibly degraded. It's not just a neat metaphor, it's a hard law of physics. And what that means is there are real, physical, finite limits to economic growth. You just can't grow forever. And that one idea, that became the bedrock for a whole new way of thinking, ecological economics.
Okay, so Georgescu-Roegen was looking at classical thermodynamics, but he wasn't the last economist to look to physics for inspiration. Now, let's fast forward a bit and get into something a lot weirder. Let's talk about quantum leaps in finance.
Yeah, more recently, a new breed of thinkers called econophysicists have started looking into the truly bizarre world of quantum mechanics. And they're trying to use it to explain something that has stumped traditional economists forever: why financial markets are so darn wild and unpredictable.
So what is quantum finance? Well, the core idea is that it just completely throws out the old textbook model of markets being efficient and predictable. Instead, it says, nope, markets are inherently uncertain, they're probabilistic. Here's a way to think about it. A stock price isn't one single number at any given moment. It's more like a wave of possibilities, a superposition of many different prices. And it's only when a trade actually happens, when an observation is made, that this wave collapses into one single concrete price. Weird, right? So this really highlights the massive difference in thinking. You've got the classical models like the super famous Black-Scholes formula, which are all built on the assumption that markets are efficient and that we, as humans, are rational actors. But the quantum model says, no way. It assumes markets are fundamentally uncertain, and that very uncertainty is what allows for things like arbitrage, finding and profiting from tiny price differences because the market isn't perfect. This quantum view is also way better at explaining things like sudden market crashes, which the old models basically dismissed as one-in-a-billion-year events that shouldn't happen.
All right, I know what you're thinking. This sounds incredibly advanced, maybe even a little mind-bending. But here's the big question. Is this brilliant, groundbreaking science, or is it all just a really, really flawed metaphor? And this is where the skeptics really have a field day. You see, a major critique points out this one giant problem. Real quantum mechanics, the stuff physicists do, absolutely relies on a specific kind of math. Math that uses imaginary numbers to describe all that quantum weirdness. But the quantum finance models, they don't actually use that core mathematical engine. So the critics look at this and say, look, whatever is making your financial models work, it's not actually quantum. It's something else. You're just using the language as a clever metaphor. And you know what? This isn't a new kind of criticism. If you go back and look at Georgescu-Roegen, he faced almost the exact same kinds of attacks. Critics claimed he didn't really have a deep enough understanding of thermodynamics. Mainstream economists basically patted him on the head and said his work read more like applied physics than actual economics. And then you have whole other schools of thought like the Austrian school, who just reject the entire premise from the get-go. They say trying to reduce economics to a math problem is a fool's errand.
And that brings us full circle, right back to that fundamental problem we started with. Like another Reddit user said, the reality is that economics lacks consensus because economic hypotheses are untestable without fabricating imaginary test economies. It's that core challenge, that untestable nature, that just keeps coming up again and again. So after all that, where does this leave us? Well, it leaves us smack in the middle of what you'd have to call a deeply unsettled science. So let's just quickly recap the big competing ideas here. First, you've got your mainstream, or neoclassical school. They're still trying to make economics work like a hard science, using all those mathematical models and that ceteris paribus assumption. Then you've got the ecological school, the intellectual descendants of Georgescu-Roegen. They say you have to integrate the actual laws of physics, like entropy, directly into your theories. And finally, you have the Austrian school. They throw out the math-heavy approach entirely and argue that economics is a deductive science, more like logic, built on the simple truths of human action. At the end of the day, economics will probably never achieve the kind of predictive certainty that physics has. And maybe that's okay, because what's really valuable here is the cross-pollination of ideas itself. This whole process, the borrowing from physics, the arguing, the clashing of worldviews, it forces us to constantly question our most fundamental assumptions about how our world and our economy actually works. And that really leaves us with one final, fascinating question to chew on. If the economy isn't some perfect, predictable machine that's governed by timeless, universal laws, then what in the world is it?